Hello everybody. Okay, so in this video we're just looking over Venn diagrams, the history of Venn diagrams and set relationships with Venn diagrams. So over here, Venn diagrams. Venn diagrams use overlapping circles to show the relationship between two sets. Each circle represents a set and the overlapping parts show elements that are shared. These diagrams help us to understand operations like the union of sets. That's everything in either set. The intersection, which is just what's in both sets, and then the complement of a set, which is what is not in the set. So when we're plotting out a Venn diagram, all shared elements go into these overlapping parts because they're both shared by each set. That is called the intersection. So these were made by a lad called John Venn. So John Venn in the 1800s was an English logistician and philosopher, and he created the Venn diagram, a simple and beautiful and powerful way to represent sets. So we first need to be familiar with how with set Venn diagram relationships. So A union B. So A, U, B. This U symbol here means union. And that is all the elements in A or B or both. So it's all the elements in A and B without repetition. So for example, A is 1, 2, 3. B is 3, 4, 5, 6. The union of them two sets would be everything shaded in the Venn diagram. So if we were to plot these out in the Venn diagram, we always work from the inside out. So first we need to see if they have anything in common. We both have a 3 in common here. That would be a 1 and a 2. And here would be 4, 5, and 6. So if we see here, right, the union of these sets is just all the elements in the Venn diagrams together. So A union B is 1, 2, 3, 4, 5, and 6. The intersection is denoted by this like upside down U shape or N shape. I always go intersection. It makes an N shape. So if we see an N sound, so if we see like the N shape, that means intersection, like intersection. So A intersection B. Intersection is just elements that are common to both. Again, so these two are the same sets, right, as up here. These two are the same sets as up here. So looking here, the intersection is what's shared in both sets, and 3 is shared in both sets. Right. The universal set is the big box around my two Venn diagrams here. And that contains all elements under consideration. Every set is a subset of the universal set. So the universal set is here. I have set A, which is 2, 3, 4. So 2, 3, 4. I have nothing in B, so ignore that. And then whatever elements we have left over, so I have 1, 5, and 6 over, they go on the outside in the box. And then finally, the last one is the complement of a set. So elements in the universal set that are not in A. That is usually given by a little tick or by a little C. So A tick or A comma just means everything not in A. So, for example, I have a universal set here. 1, 2, 3, 4, 5, 6. So this is the same up here. So everything not in A. So what's not in A? So this is all of A here, this entire circle. What's not in A? What's not in A is 1, 5, and 6. So the complements of set A is 5. So let's have a look at questions. Filler alert. Fine. Let U be the universal set. The natural numbers from 1 to 12. So that is just 1, 2, 3, 4, 5, 6, 9, 11. And P is 1, 2, 3, 4, 6, 12, and Q is 1, 3, 9. Complete the Venn diagram. So when we're plotting a Venn diagram, plotting a Venn diagram, we always work from the inside out. So let's look at the intersection. Do P and Q have anything in common? They both have a 1 and a 3 in common. So I'm going to write that in the center. 1. They also have, they don't have anything else in common. So I continue on. So what goes here is 2, 4, 6, and 12. And here is just 9. But now you see here, we are right. We haven't used every element in our universal set. So we've used a 1, we used a 2, we used a 3, 4. We've used a 6, we haven't used a 7, we haven't used an 8, we haven't used a 10, we haven't used an 11, we haven't used a 9, and we haven't used a, and we used 12. So the elements we have left in a universal set are not in either set are 5, 7, 8, 10, 11. And where do we write them? We just write them outside the set. There, 5, 7, 8, 10, 11. Fine. Find P intersection Q. So intersection, that just means what's common in both. Well, what's common in both is 1 and 3. We can see from our diagram. P union Q just means all the elements in P and Q without repeating ourselves. So that would be 1. So just be all the elements here. All the elements in my 2 circles. So that would be 1, 2, 3, 4, 9, 12. And then finally find P complement, right? The elements not in P. So this is the set P, this entire circle set P. So P complement is all the elements not shaded green here. And that is equal to 5, 7, 8, 9, 10. That's how we plot a Venn diagram. Let's have a look at some here. Let U be numbers 1 to 16, and let A be the multiple of 3. So a multiple of 3 is 3, 6, 9, 12, 15. Multiples of 5, which is 5, 15. And that's it. We can't go past the 16 because we can only use the elements in my universal set. Complete the Venn diagram. So again, working on a Venn diagram, we work from the inside out. And the only elements that A and B share is 15. Write that there. So on my A side, I'll have 3, 6, 9, 12. So sorry, I forgot to mention, we draw a little dot next to all of our elements. And then B, we have a 5 and a 10. Now, as you can see here, though, we haven't used every element in my universal set. So we haven't used a 1 nor 2. We've used a 3. We haven't used a 4. We've used a 5. So we've used a 3. We've used a 5. So the multiples of 3. And then the multiples of 5. So what I'm left with now is 1, 2, 4, 6, 7, 8, 11, 13, 14, and 16. We write them all on the outside. So list the elements in A intersection B. So intersections, the N means intersection. So what do they have in common? They both have a 15. So it's very important as well when we're answering these questions to draw the squiggly bracket. What about A union B? That's everything in the shaded Venn diagram here. So that is just going to be 3, 6, 9, 12, 15, 5, and 10. Then A union B complement. So this is A union B. So A union B complement is everything but that. So that would be 1, 2, 4, 8, 11, 6, 13, 14, 7, and 16. A number is chosen at random from the universal set. Using this information, calculate the following probabilities. The probability of getting something in A union B. Probability of A union B. So that is getting something in 3, 6, 9, 12, 15, 5, or 10. So that's 1, 2, 3, 4, 5, 6, 7. That'll be 7 over 16. A intersection B. So there's only one element. So we have a 1 in 16 chance of getting that. and then probability of A intersection B complements. So that's everything not in the intersection. So that'll be 15 over 16. Because there's 16 numbers there. Right, nearly there. Fill in the Venn diagram given X is Nicola and Y is Sophia. So first, inside out, you both have an A, you both have an I. So I, A. Oh, and you both have an O. Oh, so over here I have an N, C, and an L. Over here I have an S, E, and H. Write down a subset of X that has two elements that is also a subset of Y. So there's something in my intersection. So that's a subset of X, but also a subset of Y. So like I, A. Write down a subset of X that has two elements that is not a subset of Y, but that could be NC, right? NC is contained in my set X, but it's not in set Y. Finally here, Dee, Marie, Ray, Evan, and Fiona all use Snapchat. Dee, Marie, and Ray use Twitter. Zach doesn't use Snapchat or Twitter. Use the information to complete the Venn diagram. So, we have Snapchat and Twitter. So, let's see, inside out, who uses both? Dee and Marie use both, and Ray. So, Dee, Marie, and Ray. That means Evan and Fiona use Snapchat only. And then we have poor Zach here, who doesn't use either, so he goes on the outside. So list the elements in S intersection T. So who uses Snapchat and Twitter? Well, that's D, Marie, and Ray. S complement, so everything. So who doesn't use Snapchat? That is just. Finally, let's put a tick in each box. So true or false? The cardinal number of S is 3. That is false. The cardinal number of S is 1, 2, 3, 4, 5. D is an element of Twitter. It's T. That's true. S union T is the same as T union S. That's the same. T is a subset of S. That's true. And then this last one here, ignore that. So, yeah, that's it all. I hope it was some help to you guys. And I'll catch you guys later. Bye.